variable subject. And let's go for the next one, pseudocode. This is another way of representing the algorithms. So pseudocode means it's a written or outline of how a program or a process works using easy to understand steps in plain language. So basically using pseudocodes, we can plan our computer program or else computer software from start to the end, how the data is flowing and how the calculations are flowing and how the inputs and outputs are flowing. So all these things can be considered and we can check whether they are correct or not using pseudocodes. So when it comes to the definitions of pseudocode, you can take pseudocode is a written outline of how a program or process works using easy to understand steps in plain language. And there is a core difference between programming language and pseudocode. The programming languages are executable. So that means if you execute or else if you run the program, definitely you can get some output. For example, if you develop a program to check the check the total of two numbers, so at the end of the program process, you can see the total of two numbers. But pseudocodes, they are not executables. They are just a written outline that helps you to design the software program. So that is the core difference between a programming language and a pseudocode. So when you are creating a proper pseudocode, make sure it helps you lot to develop your program very accurately. And let's see what is the meaning of pseudocode. If you divide the total word pseudocodes into two, pseudo means fake or else unreal or else not real in Greek language. And codes, you obviously know what is the meaning of codes. So simply the pseudocode means non-real codes or else fake codes. It looks like the programming codes, but it doesn't the same. So that's why we call them as pseudocodes. So now let's see what are the basic structures of a pseudocode. So first we need to define variables that we discussed little earlier, and the inputs and outputs we have to define them very clearly to see the correct calculations, and processes and the calculations based on the inputs and outputs only the process and the calculations are happening. So these two things are actually going hand in hand. So make sure when you are design a pseudocode, you have designed or defined these things very accurately. And then control structure and function calls. So these are the basic structure when it comes to the pseudocode. Okay, so this is one of the example that I can give you for a pseudocode. Okay, first, as I said earlier, there is a start and a clearly defined end of this process, and you can see the inputs as well. So, and after the input, you can see the number one and number two. So these number one and number two means the variables. So in this pseudocode, basically two variables are inputting, and after that we are calculating the sum of those two variables, and finally we are collecting the total of that sum. So this is the basic structure of a very simple pseudocode, and now I'm going to show you how a real programming code looks like. Okay, so this is a real programming code. For example, now earlier example, I showed you the entering the first number and the second number. So when it comes to the programming code, this is how it's made. Okay, the num1 and num2, these things are called as variables, and float means the data type, and after that the input command is there, and simply there is a message to input the first number and the second number. And then the calculate the total. So now the calculation is happening inside the programming code, and finally it's showing the result. If you put first number as 1 and second number as 2, finally and ultimately you will get the result as 3 at the end. So that is how programming code works, and this is executable, and you can see the different code difference between a programming code and a pseudocode. Now let's talk about what are the common rules when it comes to the pseudocode. When we are developing or designing a pseudocode, make sure we are using plain language that is easy to understand. So that language use must be very concise and precise, and make sure you are not getting it complicated. So when you are designing a pseudocode, make it simpler, make it very understandable way. So that is one rule when it comes to pseudocode. We have to use very plain language in terms of applying to pseudocodes. And then we should include a clear input and output, because in computer science and in computer language, when we are giving commands to the computer, we should give a clear input or output operations. So based on those things only, the computer language can perform actions or else perform calculations based on the inputs you have given clearly. And avoid syntaxes. So earlier example, you saw how the real code looks like. So in that real code you must have seen different syntaxes. So we cannot use different syntaxes when it comes to pseudocode. It should be plain language. So when you are designing a pseudocode, make sure to avoid all the syntaxes in that pseudocode. And next, these pseudocodes and flowcharts are like going hand in hand. I will show you example later. So we can use pseudocodes and flowcharts together. So that is one of the very important point when it comes to flowcharts and pseudocode. They are like going very hand in hand. So you can use pseudocode with flowcharts as well. And for inputs, outputs, or else any other important messages, you need to use double quotation marks. So for example, I have put if you want to enter your name, you can put that word in inside double quotation. So this is how it works when it comes to making pseudocode. So this is one of the most important role when it comes to pseudocode. And then write and stop, start and stop. So basically, as I said, when you are defining a pseudocode, make sure you are giving the correct start point and the correct end point. So if you fail to give the exact endpoint, the program will not work properly. And if you convert the pseudocode without endpoint to a programming code, that program will not work properly. So make sure you keep in mind these things when you are designing a pseudocode. The start and the stop location should be clearly defined. And this is one of the example for a pseudocode. As you can see, this is combined with a flowchart. You can see the start here very well at the beginning, and then with the parallelogram symbol you can see one input, and with the second parallelogram you can see another input, and after that with the rectangle button you can see a process is happening, and after that there is a output with again with a parallelogram sign, and finally it's ending the process. So these are the things that we are going to learn when it comes to computational thinking and programming, and I hope this lesson is clear for you. So if you have any questions, let me know. I'm here to uh, assist you with that. So thank you very much for watching, and see you with the next lesson. Bye bye.